Welcome to this PINE+RAIN Studio Explainer, System Architects and Engineers. Let's jump right in. Today we're looking at a fascinating and frankly kind of concerning trend. We're going to explore how modernity is actually unsolving our tech stack. For decades, the entire point of progress in software and hardware was moving towards absolute precision and reliability. But today, well, we're trading deterministic fidelity for probabilistic vibes. We are literally swapping absolute control for mere convenience and local ownership for cloud access. And the result? A technological landscape that might look a lot more sophisticated, but is actually far less reliable than what it replaced. So, today we're going to walk through a structured teardown of modern technical architecture. We'll diagnose semantic entropy, look at AI and the visual prior, contrast cloud dependency with actual tool control, define the judgment tax, and finally, go over some blueprints for building local first architectures.
All right, Section 1, the era of semantic entropy.
To really grasp how we lost control over our tools, we actually need to look back at philosophy for a second, specifically Ludwig Wittgenstein's rule-following paradox. He noted that a rule cannot contain the instructions for its own application. Now, in the past, traditional software closed that philosophical gap by using really rigid, unforgiving syntax, right? If you missed a semicolon or passed an integer instead of a string, the code just didn't compile, it crashed. And yeah, sure, that could be super frustrating in the moment, but it meant the machine was a perfect subordinate. It did exactly what you told it to do. But modern AI, it fundamentally rips this gap right back open. It treats our strict rules as mere suggestions within a vast probability field. And for any engineer concerned with system reliability, that gap is an absolute nightmare. When you can't guarantee that an input will produce the exact same output every single time, true reliability becomes practically impossible. This brings us to a massive regression highlighted in a 2026 Stanford study called The Limits of Prompt Adherence. Basically, on one side, we have the solved state, imperative computing. This means do exactly this, which yields 100% deterministic fidelity. On the other side, we have our current unsolved state, stochastic mimicry. This translates to something more like, hey, do something that looks kind of like this, based on general vibes. Think about the sheer latency and the debugging nightmare this causes. We have literally regressed from issuing strict one-to-one imperative commands with totally known execution paths to crossing our fingers and just hoping the probabilistic vibes align with our engineering intent. We are playing guessing games instead of building reliable systems. Moving on to Section 2. AI and the visual prior. So let's look at a really specific example of this instruction paradox failing in real time. We call it the YouTube banner paradox. First, you have to understand the visual prior. This is basically a statistical average of what an image should look like to an aesthetic algorithm. Back in the days of coordinate geometry, a front-end dev or a designer could dictate pixel-perfect boundaries. You knew exactly where the blank space would be, no questions asked. But today, if you ask generative AI to leave a precise, mathematically defined blank space for text on a banner, it gets totally blinded by its visual prior. It decides that, statistically speaking, banners usually have graphics spanning the whole canvas, so it just fills your meticulously calculated empty space with aesthetic noise anyway. It completely bulldozes your mathematical constraints based on a statistical assumption. Which brings us to a critical question for any software engineer concerned with latency, reliability, and precision. Why does an aesthetic algorithm just ignore explicit mathematical constraints? And, more importantly, why do we accept tools that treat our rigid mathematical instructions as mere suggestions? A tool that guesses your intent instead of executing your explicit command isn't just quirky. It's fundamentally broken when it comes to system reliability. Let's hit Section 3, Cloud Dependency versus Tool Control. This loss of absolute control, it builds way beyond just generative AI. It infects our fundamental computing infrastructure right down to the metal, and largely, it does this through cloud dependency. We've totally abandoned absolute local ownership for rent-seeking computing and latency. Let's actually trace this across 3 major domains. In logic and AI, we traded the perfect fidelity of Boolean syntax for the probabilistic guesses of latent manifolds. In media, we traded the solved zero-latency cohesive broadcast of a unified system for fragmented, high-friction, siloed apps. But the biggest hit for system architects is in computing itself. We traded local hardware ownership, where your tools worked instantly, completely offline, and under your total control, for cloud sauce dependency. Just think about how much friction that adds to your daily workflow. Every simple task now requires a round trip to a remote server. You're paying a constant latency tax just to operate your own environments. To put a psychological frame on this, we can look at the philosopher Martin Heidegger.
He described tools that work perfectly as ready to hand. They act as a seamless, deterministic extension of the self. Think of a really good physical hammer or a locally installed IDE running purely on your hard drive. It just works. You don't think about the tool, you think about the task, right? But today, because of cloud dependency, we've shifted to tools that are present at hand. These are tools we are constantly made aware of because they're buffering, demanding subscription renewals, or just failing entirely. Think about the psychological toll this takes on engineers responsible for a system's uptime. When an authentication server hundreds of miles away in Northern Virginia goes down, your localized, hyper-expensive hardware instantly becomes a brick, literally a paperweight. And that is the ultimate definition of losing tool control.
All right, Section 4, the modern judgment tax. All of this regression across AI guessing games, fragmented media, and incredibly brittle cloud computing, it culminates in one really painful reality that I'm sure you all feel. We are paying a massive judgment tax. See, we've successfully automated the easy surface-level stuff, but we have made foundational reliability incredibly complex and incredibly expensive. Just look at the tangible burdens we're eating right now. In AI, the tax is the wasted hours engineers spend doing manual verification of code because they can't trust the automated output not to hallucinate. In streaming, the tax is the search friction, navigating absolute UI labyrinths just to find a single asset across 5 different subscriptions. And in the cloud, the tax is managing constant bandwidth and connectivity overhead just to open a simple localized text document. 85%. That number right there is the heart of the judgment tax. We sacrificed absolute 100% perfection for good enough probabilistic fidelity, which hovers right around 85%. But here's the thing. That missing 15% isn't just a margin of error. It is a tax paid in human hours, in tedious manual verification, and in constant system vulnerability. It leaves software engineers and end users constantly having to bridge the gap of unreliability that modern tools have created. Which brings us to Section 5, building local-first architectures. The good news, we don't actually have to live with this unsolving. As architects, we absolutely have the power to fix this and get our determinism back. The answer lies in a concept called neurosymbolic integration. Now, this isn't just some AI strategy, it is a full-blown digital philosophy. For a working system architect, this means fundamentally re-establishing the machine as a perfect subordinate. It's a highly practical design choice to end the era of unpredictable magic and return to tools that simply do exactly what they are told. Instead of letting neural networks freewheel through your backend, you anchor them to symbolic logic. You dictate the terms of operation, returning absolute control to the user and completely eliminating the guesswork. So, here is your blueprint, the specific, actionable steps to resolve your architecture today. Step 1, build local-first software. This is not just a buzzword, okay? It's a foundational requirement for zero-latency, high-reliability architecture. Eliminate latency by ensuring your core tools run locally and deterministically. You use the cloud only as an optional backup or syncing mechanism, never as a tether for core functionality. Step 2, implement symbolic guardrails. Look, you don't have to completely abandon AI, but you absolutely must wrap your probabilistic models in strict, non-negotiable logic cages. A logic cage is a hard-coded constraint that refuses to let an AI output anything violating a spatial, mathematical, or syntactic rule. If the AI hallucinates, the cage blocks it. Boom, done. And step 3, embrace aggregated standards. Prioritize universal, open protocols over fragmented walled gardens to finally regain interoperability. Look, technological progress is not a straight line. It is a series of trades. For 30 years, we traded raw power for precision, and recently, we mistakenly traded that hard-won precision for magic. As you architect your next system or write your next code base, I want to leave you with this final, really vital thought. Are we building perfect subordinates or temperamental partners? It is time to reject the judgment tax, abandon the magic, and build local-first systems that simply do exactly what they are told. Thank you so much for joining me for this explainer, and keep building locally.